Okay, this is part 2. We're going to look at the relationship between chords and their intercepted arcs. And we're going to look at these as far as a proof, because one of the things that they really emphasize in the analytic geometry course is that you guys are very familiar with what proofs look like, how to write proofs, how to understand a proof, and be able to understand the reasoning behind why these theorems and postulates came to be. In this example, whether you have the same circle or if you have two congruent circles, if the chords are congruent in congruent circles or the same circle, then their intercepted arcs would be congruent. So we're going to prove that statement. So if you're given chord AB, you're given this chord right here, AB, and chord CD are congruent. We're going to prove that arc AB is congruent to arc CD. Now, the first statement they gave there, the reason is just given. That was what they started with. They said, okay, if you're given two chords that are congruent, then we're going to follow the process to prove that the arcs are congruent. So this next line here, it's showing that EA is congruent to EB, and is congruent to EC, and is congruent to ED. And the reason that all four of those are congruent is simply because they're all radii of the circle. And if you have radii of congruent circles or the same circle, all those radii would be congruent. So therefore, we can set all the radius equal to each other. So what we have here is we've got two sides that are congruent. In these two separate triangles, you have AE and CE, you have BE and DE, but you also have a third side, AB is congruent to CD. That means that you have two congruent triangles there. You have triangle AEB and triangle CED are congruent because of the side congruent postulate. Once you have congruent triangles, you can then say that all other parts of those triangles would be then congruent. In other words, now that I know that triangle AEB is congruent to triangle CEB, I can then say that this angle right here, AEB, would be congruent to this angle, not triangle, angle CED. That is one of the important ones that we were supposed to learn back in Unit 1, is that once you have proven two triangles are congruent, then therefore all other parts of those two triangles are also congruent. CPCTC, that stands for corresponding parts of congruent triangles are congruent. So now, first we proved the two triangles are congruent. Then we were able to say that those central angles right there, that's what the AEB and angle CED are, they're central angles, they are now congruent. Well, then we also learned that if this central angle is congruent to this central angle, the measure of the intercepted arc will also be the same as those central angles. Therefore, those intercepted arcs would have to be congruent as well. And now we're going to prove that converse of that by showing that if you have a same circle or congruent circles, if the arcs are congruent, then therefore the chords would be congruent. So in this one, we are given that arc AB and arc CD are congruent. They're saying this arc AB and this arc CD are congruent. Well, if that is the case, then you also know that this angle here and this angle here are congruent. So that's because the central angle is congruent to the intercepted arcs. And since the central angle is congruent to the each intercepted arc, therefore the angles would have to be congruent, so you're just substituting. So instead of saying AEB, you could just set those equal to each other since the arcs are equal to each other. We substituted angle AEB in place of the AB in the first statement. We substituted angle CED in place of arc CD from the first statement. So we basically substituted from that first statement up there. Then, again, like we saw in the last one, if you have radii, the radii are all congruent. And so in this one we have side, angle, side, side, angle, side. So we are proving that these triangles are congruent by the side, angle, side theorem. Now that we've proven that the triangles are congruent, we can then also say that, this chord AB is congruent to this chord CD because those chords would be corresponding parts of congruent triangles. So by CPCTC, once we prove those two triangles congruent, we now have corresponding parts. Chord AB and chord CD are now also congruent. So let's just practice that with a couple of examples. The theorem states that if you have two chords that are the same, in other words, in this example, RS would be congruent to VT. So if it told you that the measure of arc TV is 121, right, this arc right here is 121 degrees, then this arc right here would also be 121 degrees because since the chords are the same, their arcs must be the same. So 121 degrees there. And vice versa. Here we see that we have this measure of this arc intercepted with F and G, and this arc EG are congruent. So therefore, chord EG would have to be congruent to chord FG. So that would make FG equal to 6. And that will conclude part 2 of this lesson.